In this video, we're going to talk through the section check keys for section checks 9.1 through 9.3. All right, let's take a look at question 1. Write the standard equation for the ellipse and describe which is the major and minor axis. So really what's going on here with ellipse, and I've got two equations listed here. One is the horizontal major axis. So if it gets stretched more in the x direction, we get a horizontal major axis. And what does that stretching is if this a value is larger than the b value, then the value under y, notice if the value under x is larger, then it's going to stretch it more in the x direction. Well, if you stretch it in the x direction, we're going to get a major axis that's horizontal. And then over here again, if we stretch it more in the y direction, a is again bigger than b. If we stretch it more in the y direction, then we're going to get a vertical major axis. So really what's happening here is if we just looked at our equation of the circle, we got this x squared plus y squared equals 1. That's a circle, so there'd be no stretching in either direction. Now if I start dividing by these values down here, it starts stretching this out to make an ellipse. And whichever value is larger is going to be the major axis. So it doesn't matter the order here. Notice this is addition, so the way these equations are written, it's like, x squared is first here, and y squared is first here. Well, that doesn't matter. What matters, since it's addition, is whichever has the larger value under it is going to be stretched more, and that will be the major axis. All right, let's take a look at question 2. Question 2 now. Graph and identify the location of the foci. So we got to get this guy right here, this equation right here, to look like this. And notice we need to have 1 on the right side. So the first thing I'm going to do is go and divide every term by 196. And when I do that, I'll get 1 on the right side, and I'll get 4 over 196, 49 over 196. Let's see if I can highlight this. 4 over 196, no. Okay, so anyways, we're going to go through it. We'll divide 49 out of the numerator and denominator here, which simplifies then to x squared over 4. We'll divide a 4 out of the numerator and denominator here, which then simplifies to y squared over 49. Now notice, more stretching here. So we are going to have a vertical major axis. We're stretching the y more. Okay? Now, let's look. We need to first find the center of our ellipse, and notice there's no plus or minus here on these values for x squared and y squared, so there's going to be centered right at the origin here is our center. And now notice in the x direction, it's going to get stretched since b squared now is 4, it will be 2 in each direction. So you can see me going 2 to the left, 2 to the right. And then here, y squared over 49, so the square root of that would be 7. So it's going to go stretched up 7 and then down 7. So there are my vertices. So I'm going to go ahead now and draw my ellipse. Now to find the foci, the equation for finding the foci is this. In an ellipse, it's c squared equals a squared, the larger value, minus b squared, the smaller value. And so you can see me doing that right here. So c squared is going to be 49 minus 4, which is 45. Square root of 45 is approximately 6.7. So now I'm going to go back to my origin, and then I'm going to come up 6.7 and down 6.7 to find the foci. So up 6.7. Down 6.7 to find the foci. All right. Taking a look now at question 3. Graph and identify the location of the foci. Well, so this one is going to be a little bit trickier here. We're going to have to use completing the square to do this. You'll notice I have some x terms here and some y terms, but let's look a little more closely at this. So here are my x's. I've almost got a trinomial there, 9x squared minus 72x, but I'm missing a term. Same thing with y here, 4y squared plus 16y, but I'm missing that final constant term. I could try to use the 24 to get those constant terms, but I think it's easier just to get 24 out of the way, and then we'll look at completing the square. So that's the first thing I'm doing, is I'm going to subtract 24 from both sides, and that's where I end up like this. Now, when I look at my almost trinomials here, I want to find this value. So I have a perfect square for my x trinomial, and then I want to find this value here. So I have a perfect square for my y. It's harder to find that perfect square if our leading coefficient is not 1. So usually what we do is we look to see if we can factor out a greatest common factor here, and we can in both cases. So you can see me in this first one, I'm factoring a 9 out of each of these terms. And I'm factoring a 4 out of each of these terms, because that's the greatest common factor. When I do that, I end up with this. I end up with x squared minus 8x. And now I want to find that value so that I have a perfect square. If our leading coefficient is 1 now, which it is, you can see right here, leading coefficient of 1, then c, my last term, is going to be 1/2 b squared. So c, if my leading coefficient is 1, is 1/2 of b squared. And so if I come back over here and look at b, b is -8. 1/2 of -8 is 4. 4 squared is 16. And you can see that's where I'm getting this 16 there. So now this is a perfect square trinomial. Now, I added value. When I put that 16 in there, I've added value to the left side of my equation. So I need to add value to my right side of my equation over here to keep it balanced. Well, let's see how much I actually added. If I put a 16 in here, notice that 16 is going to get multiplied by a 9. So that's actually not increasing that left side by 16. It's increasing it by 144. So that's why I'm adding 144 over here on the right. Now I look at finding this value here. 1/2 of b squared. Well, half of 4 is 2. 2 squared is 4. So that's where this 4 comes from. Now notice I'm actually adding 4 times 4, or 16, to the left side. So I need to also add 16 to the right side over here. So now I go down to my next line. I add up the stuff on the right side. That gives me 36. Now I have a perfect square here. This x squared minus 8x plus 16 is actually x minus 4 quantity squared. Here, y plus 4 is actually y plus 2 quantity squared. Now I want a 1 on this side, so you can see that's why I'm going through and dividing everything by 36. Now I simplify these fractions, divide a common factor of 9 out here, a common factor of 4 out here. Now I finally got my equation looking like an ellipse. This ellipse is not centered. Notice we've got -4 here, so that's going to push it 4 to the right and then down 2. So 4 to the right and down 2, that's where I find this guy. Now let's look at the stretches. My x stretch is going to be 2 in each direction. So you can see me going 2 and 2 in each direction of the center. My y stretch is going to be 3 in each direction. So 3 and 3. Notice y has a larger value below it, so that'll be our major axes. That's where I'm going to put my foci. And again, c squared minus a squared, c squared equals a squared minus b squared. You can see me doing that right here, which tells me the foci are going to be 2.2 from the center on the y-axis. So I come back over here and I go up 2.2, down 2.2 to find my foci. All right, let's take a look at question 4. Graph and identify the foci and write the equation. Okay, minor axis endpoints of that and that, major axis of this and this. So I just went ahead and graphed those. So you can see me getting my 2 here, 2 here. And so now they give us the center. They wouldn't necessarily have to give us a center, because given those 4 points, we could still find the center of our ellipse here. But they give us a center at 1, -1. So from there, now we can just count. And so it looks like, again, my y stretch is larger. And that looked like a stretch of 6. My x stretch was just 2. And so then, once I know a and b, I can write those into my equation here. And you can see a squared, which was my y stretch, will be 36. B squared, which was 2, will be 4. And then this thing is not located at the center. Notice it's shifted center. It's shifted 1, +1 in the x direction, -1 in the y direction. So when I come to write my equation, I'll write +1 in my y direction, -1 for my x shift there. Square those guys. I've got my location. Now, if I want to know the foci location, again, it's c squared equals a squared minus b squared. So 36 minus 4 is 32, which gives us 5.7. So then I want to go to the center over here, which we said was 1, -1, and then go up 5.7 for this foci, down 5.7 for that foci. And all I did was add 5.7, subtract 5.7 from my center here to get the location of those coordinates. All right, 9.2, question 1. Write the standard equation for a hyperbola with a horizontal transverse axis and a vertical transverse axis. So the transverse axis, all that means is that's where these little parabolas, right here, which axes they're going to cross. If they're going to cross the y-axis, then that's going to be a vertical transverse. And if it crosses the x-axis somewhere, like this guy does here, that's going to be a horizontal transverse. Transverse, again, just meaning cross. So now it doesn't matter which one of A or B is bigger. Remember, in ellipse, A or B, whichever was larger, determined our major or minor axes. Here, it's which one comes first. So if x comes first, then we know we have a horizontal transverse axis, and our parabolas are going to open left and right, like this guy here. And if our y comes first, then it's going to be a vertical transverse axis, and we're going to get our little parabolas opening up and down, like this picture here. All right, let's take a look now at question 2. Write the equation for each hyperbola and write the equation for each asymptote. Let's scroll up here a little bit here so we get the equation in there. Okay. So we're looking at this first one here. Looking at this first guy here. We notice that it's going to be a vertical transverse. So we're looking at this equation here. It's centered at the origin. Notice our two asymptotes are centered at the origin, so I don't need x plus or x minus anything, or y plus or y minus anything. All I need to do now is kind of figure out A and B. And so if we look and we count up A, it looks like it's going to be 5. And if I look at B here, it looks like it's going to be 3. So I know that my A is 5, or the stretch or the shift here in the y direction is 5. And B is 3. So now I want to square those in my equation, and that's where I'm getting this 25 and this 9 from. The asymptotes, these are nice and easy to find because these are just equations of a line here. Notice my y-intercept is 0. It's crossing the y-axis in both cases at 0. So all I got to do is find the slope of these. Well, that's pretty easy. Remember, to get this point right here, we would go up 5 over 3. That's the slope of my line. And so you can see that's where that asymptote is coming from. 0 for a y-intercept and a slope of 5/3. And then this guy now is going downhill. So if I start at this point, 0 y-intercept, I'd go down 5 or negative 5, right 3. And so you can see that's where I'm getting this asymptote. Okay, let's take a look at my next hyperbola here. All right, so this guy is going to be x squared first, because notice we're traversing an x-axis here, opening left and right. It's not centered now. The center of this guy, and I counted that out, was 2, negative 3. And so you can see positive 2 in the y direction, positive 2 in the x direction, negative 3 in the y. So since it's traversing an x-axis, x is going to come first, and it's minus 2, x minus 2, since our center was at positive 2, and then y plus 3, since our center was at a y coordinate of negative 3. Now, once I've got that in place, all I got to do is figure out these values down here. So I just count out. So let's get our x movement here. So I start here at the center, and it looks like I'm going out 1, 2. So that would give me a 4 down here. And then the y looks like 3. 1, 2, 3. So that's where this 9 comes from down there. Now let's go ahead and write our equations for our asymptotes here. Let's see. Let's erase some of this stuff. Okay. All right. So looking at my asymptotes here. So this line right here, this guy right here, notice it has a y-intercept of 0. All we got to do is figure out its slope. Well, that's super easy. Just go to the center and count it out. looks like I'm going down 1, 2, 3, over 1, 2. So negative 3, 2. So there's my first asymptote, 0 y-intercept, and a negative slope of 3/2. All right, let's go to my next one. Notice this line has a y-intercept of 8, 7, 6, negative 6 y-intercept, and that same slope but positive. So it looks like I'm going up 1, 2, 3, over 1, 2. So up 3 over 2 for my slope, y-intercept of negative 6. And so there it is, slope of positive 3/2, y-intercept of negative 6. Okay, question 3. Graph and write the equation for each asymptote. Well, the fact that they're saying that we got an asymptote here, we know we're probably going to end up with a hyperbola. This is just like that last problem. We're going to have to complete the square, that problem we did with an ellipse. So first thing I'm doing is I'm getting that negative 63 over to the right side, and I'm saying, all right, I want values here so that I can complete that square. It's easier to complete that square if I factor out the greatest common factor first. So in these first two terms here, I'm factoring out a 9. In these first two terms here, I'm factoring out a negative 4. All right? Because I want to make sure when I get done with this equation that I have a minus sign in here. So that's why I'm factoring out a negative 4 right here, not a positive 4. Okay? So I'm looking for this value. Remember, that value for a perfect square is 1/2 b squared. Well, negative 2, 1/2 of that is negative 1. Square is positive 1. So that's where that positive 1 is coming from. Now notice I've increased the left side of my equation by 9 times 1, or 9. So I'm adding 9 over here to the right side. Looking at my next one where I want to have a perfect square. Well, this value here, 1/2 of b squared, 1/2 of negative 6 is negative 3. Square it is positive 9. Notice I increased the left side of this equation now by negative 4 times positive 9, or negative 36. I guess I've decreased it by negative 36. And so you can see me subtracting 36 from the right side as well. When we do that addition and subtraction over here, we'll get 36. And now we have our perfect squares. This is going to be x minus 3 squared. This is going to be y minus 1 squared. Notice I got this 36 over here, so the next thing I want to do is I want to go through and divide all of these terms by 36. And you can see that's what I'm doing right down here. Simplify by dividing out our common factor of 9 here, common factor of 4 there. So I get this is my equation. All right, now I want to graph it. Well, let's start with the center. Notice y is minus 1. So that would move the shift positive 1 in the y direction, minus 3 here, so positive 3 in the x direction. So that would be over 3, up 1. You can see that's where I'm getting the center. Now let's look to make this kind of box around there, kind of make this, this rectangle around that point. Our stretch in the y direction is the square root of this, or 2. So you can see me going up 2 and down 2 from the center. The stretch of our rectangle here in the x direction is the square root of 9, or 3. So you can see me going left 3 and right 3. Now, once I have that rectangle, those points on there, I can kind of dash in and draw this rectangle around there. Draw my asymptotes through each of the edges, the corners of my rectangle. Those are my asymptotes. And then notice since y was first, this is going to be a vertical traverse. So it's opening up and down. And you can see my parabola opening up and down here. That's how I know which way it's going to traverse. Now, to find these asymptotes is a little trickier. Let's erase some stuff here to see what we've got. Okay, so the slope is going to be just the slope. So always best to find the slope. Go to the center here. Go to the center here. And let's go out to one of these edges. So notice that was up 2 in the y direction, and then 3 in the x direction. So that slope is going to be either positive, we said up 2, change of y of positive 2, positive 2/3 for this line going up, or negative 2/3 for this line going down, or negative 2/3 for this asymptote coming down here. Okay, now these are not so easy to see my y-intercepts here. It looks like I got a nice y-intercept there, Oh, I guess I have a nice y-intercept there as well, too. So we could find those out. We could go ahead and look at our graph there and figure out my y-intercepts, and I could go with these positive slopes and go straight to these asymptotes here. That's one option. Sometimes when these points are not easy to see, these y-intercepts are not easy to see, it's easy then to go with the point-slope form of an equation, and that's what I've written right over here. So all you do is you take my slope, which in this case would be positive 2/3 or negative 2/3, and then put in the point that it's going through. Well, the center of this graph is a point that it's going through, and that's where I'm getting this. See, since the center of my graph here, let me write this down. The center of my graph was over 3 up 2. So I'm just plugging that into the point slope form here. Here's my slope, plus or minus 2/3. Here's my point. X coordinate of 3, so that goes in as minus 3. Y coordinate of 2. Oh, sorry, my coordinate was 1, not 2 there. Sorry, I made a mistake when I was counting. It was 3, 1, not 3, 2. So 3, 1. And then you can see that's where my y coordinate is there, going into point slope. So point slope is really quite easy to write. You just do the plus or minus, when we're doing these asymptotes, plus or minus the slope, and then you just put the center of our rectangle as the point. That's another easy way to write these equations for the asymptotes. All right. 9.3 now, write both the vertical and horizontal standard form of these equations. So vertical is the one we're used to, which is x squared is equal to something to y. So that's when it's opening up and down. And then y squared equals 4px is when it's opening left or right. So here's a y squared equation. Here's an x squared equation. So when we got x squared equals 4py, up and down, y squared, left and right. All right. So question 2 now, or sorry, I guess questions 2 and 3 is to graph each of these things, but also graph the vertex, the focus, the directrix, and the latus rectum. All right, lots of stuff that we need to find here, but really it all kind of hinges on finding the value of p. Once we find the value of p, everything else kind of just falls in place. So when I'm looking at question 2, I don't have any shifts. There's no shift going on with the x, or sorry, the y. There's no shift going on with the x. So the center or the vertex of this is going to be right at the origin. So that's where that center is coming from. Now all I need to do is find the value of p. Notice in my equation here, y squared equals 4px. This is my value of p. So all I'm going to see when I look at this, I got this negative 12 here. I'm going to divide by 4 to figure out what p is. Well, when I divide by 4, I'm going to get p is negative 3. That's what you can see right there. From there, then, I can get all the other information I need. So I know this guy's opening left and right. So I go to the center. Since p is 3, I'm going to count out 1, 2, 3. That is going to be my focus. And if I count to the right now, the back side of the parabola where it's opening, if I count 1, 2, 3, that's going to be my directrix. So I draw a dotted vertical line here at x equals negative 3. Put my focus here. I know my parabola is opening left now. All I need to do now is figure out how wide my parabola is going to be. Well, that's the length of the latus rectum. And the latus rectum is the absolute value of 4p. That's what that is right there. And so that's just going to be positive 12. So if the overall length of the latus rectum is positive 12, that means I'm going to go up 6 from here, down 6 from there for an overall length of 12, and that's how I get those coordinates. Once I have those coordinates, then I can graph my parabola going through the vertex and going through those endpoints of the latus rectum. All right, question 3. Well, it looks like, here, let's erase some stuff here. All right. So with question 3, notice this is an x squared situation. So that's like this guy. So we're going to be opening up and down, up or down here. Since this is negative, we're going to be opening down. but we've got some shifts going on here. Notice with x, we've got a shift. We've got this plus 2, which remember it'll shift the other way, so that means left 2. So we're starting at the origin going left 2. And then my y also has a shift here. -1, that means it's going to be up 1. So you can see that's where I'm getting the vertex then. Left 2, up 1. Let's figure out what p is. All we got to do is divide this value by 4 to find out what p is, and that's going to be -2. So now, once I know my vertex, I come down 2. That will be my focus. Up 2, that will be the line for my directrix. So I draw a horizontal line. It looks like at 1, 2, 3, y equals +3. Now all I need to do is figure out these coordinates to see how wide this parabola is going to open. And so that's the length of the lattice rectum. And remember, that is just the absolute value of 4p. And if we look here, that's going to be 8. So then I come down to my focus, I count out 4 to the right, 4 to the left, gives me those coordinates, then I can go ahead and graph my parabola opening down. Okay, question 4. We're asked to graph this and identify all that same information we had before. This guy is not organized the way we want it. Notice I've got a y squared in here, so this thing is probably looking like this. Y squared equals 4px is the standard form of my equation. Let's write those again. 4px. X. Okay. So we want to organize it that way. So I want to get y squared all by itself and everything else over on the other side. So let's see. Notice, though, I have this other y value there. Meaning if I'm going to end up like this with y squared something, it's going to have to be, y plus some value squared here, or y minus some value squared there. So I'm thinking about now completing the square if I need to. But it looks like I don't have to, because notice this 1 right here is 1/2 of b squared. So this is already a perfect square. So that worked out real nice. I don't have to do anything to complete the square on this one, because once I move this 8x over to the other side, I end up with this nice perfect square here. And so since this was 1/2 b squared, this is just going to be y minus 1 quantity squared equals 8x on this side. Now I've got this thing in this form, the standard form, and I'm ready to graph this. It's just got one shift here with the y. So y is going to the y value is going to get shifted up 1. No shifts over here for the x. So there's my vertex. And now I just need to find p. Well, divide a 4 out of the 8, and we'll find that p is +2. So we're going to go over here from this point, +2 in the x direction, 1, 2. There's my focus. Now on the other side, we'll find a directrix by going 1, 2 to the other way. Draw a nice vertical line there at x equals -2. Now I just need to find the endpoints of the lattice rectum to see how wide this parabola is going to open. Well, that is just the absolute value of 4p, which in this case is 8. So I go up 4 here, down 4 there to give me a total of 8, and then graph my parabola.